So, page number 6. We are multiplying polynomials by other polynomials. And we saw that when you had a binomial times a binomial, we use a distributive property. Same thing when you had a binomial times a trinomial. We use a distributive property. So this will be done exactly the same way. We're multiplying a trinomial times a trinomial. So we're going to multiply every term in one bracket by every term in the other bracket. So I'm going to do this by taking the 2x squared, the first term in the first bracket, multiplying it by each term in the second bracket. The second term in the first bracket is a positive 3x. It's also multiplied by all three terms in the second bracket. And then the last term in the first bracket, again multiplied by all three terms in the second bracket. That's the question. Yeah. Question 3a. This is a continuation from yesterday. Now you could have done it the opposite way, meaning take the first term in the second bracket and multiply by all three. Then take the second term in that second bracket, multiply by all three in the first. And the negative 1 in the second bracket, multiply it by all three in the first. You would get the same answer in the end. Okay, so either way would work. So now we're going to multiply out each bracket. Remember, coefficients first. 2 times 3 is 6. Do you have this booklet, Jensen? It's right behind you, over your right shoulder. 2 times 3 is 6. X squared times x squared. Remember, you add the exponents. Keep the base the same. Then 2 times negative 2 is negative 4. X squared times x to the 1. Add the exponents. When you multiply 2x squared by negative 1, it's just going to be negative 2x squared. 2 times negative 1 is negative 2. The x squared is not multiplied by any x there, so it doesn't change. You with this, Liam? So now we'll multiply the 3x by all three terms in the second bracket. 3 times 3 is positive 9. X to the 1 times x squared gives us x cubed. 3 times negative 2 is negative 6. X to the 1 times x to the 1 gives us x squared. Add the exponents. And then the 3x is multiplied by a negative 1. 3 times negative 1 is negative 3. The x is not being multiplied by anything, so its power doesn't change. And finally, we multiply all three terms in the second bracket by a positive 4. Because there's no x on that positive 4, none of the x's will change, just the coefficients. It'll be 12x squared minus 8x minus 4. So I'm going to do my next step, showing that I'm collecting the like terms. You don't necessarily have to do this, but if you do, it probably reduces the chances of you making a mistake. So I've got two x cubed terms we need to combine. There's three x squared terms that we need to combine. There are two x terms that we need to combine, and only one constant term. And it might also be helpful that when you write these down, cross them out above, just to make sure that you haven't forgotten anyone. So we've got the 6x to the fourth. We've got the negative 4x cubed plus 9x cubed. We've got the minus 2x squared minus the 6x squared plus 12x squared, a negative 3x and a minus 8x, and then the minus 4. So I haven't missed any. So our final step then will be combining the like terms. If you have negative 4 of something and you add 9, negative 4 plus 9 is positive 5 of those things. Remember that the powers don't change when you're adding and subtracting like terms. That only happens when you multiply or divide. Negative 2 take away 6 is negative 8. Then you're going to add 12. That'll be positive 4x squareds. Negative 3x take away 8x is negative 11x. And then you got the minus 4. So there's the final simplified answer. Okay. So question 3B, same type of question. Yes, ma'am. She's writing the quiz for me in that room across the hall. Nope. Right, so we'll start by setting up the distributive property. The 2a squared, the first term in the first bracket, is multiplied by all 3 terms in the second bracket. The negative 3a in the first bracket is multiplied by all 3 terms in the second. And the positive 1 is multiplied by all 3 terms in the second. So when you multiply out, coefficient times coefficient, 2 times 4 is 8. A squared times a squared, remember you add the exponents. Keep the base the same. 2 times negative 5 is negative 10. A squared times a to the 1, add the exponents. Keep the base the same. The 2a squared times the negative 2, 2 times negative 2 is negative 4, and in this case the a doesn't change because the a squared is not being multiplied by any a's. And for the next part, negative 3 times 4 is negative 12. A to the 1 times a squared, add the exponents. Keep the base the same. Negative 3 times negative 5 is positive 15. And then a to the 1 times a to the 1, add the exponents to get a squared. Negative 3 times negative 2 is positive 6, and this a doesn't change because the negative 3a is just being multiplied by the negative 2. There's no a there, so the a's don't change. And then everything gets multiplied by positive 1, which means it's just going to remain exactly the same. You have a positive 4a squared, a minus 5a, and a minus 2. If we collect our like terms, there's only one a to the 4th term. There are 2a cubed terms, the minus 10a cubed, minus 12a cubed. Again, there are 3 a squared terms. There are 2 a terms, and only 1 constant term. So again, we just strike out above everything we've written down to make sure we haven't missed anything. We've got a negative 10a cubed, a minus 12a cubed. We've got a negative 4a squared, a positive 15a squared, a positive 4a squared, and then you have your 6a and your 5 minus 5a, and then the minus 2 at the end. So now when we combine our like terms, negative 10 take away 2 is negative 22a cubes. Keen, what's going to happen to the minus 4a squared plus 4a squared? Yeah, exactly. Stay with us. Yes. They cancel each other out. This minus 4a squared and the positive 4a squared would cancel each other out, so you're just left with 15a squareds, which you would get if you went negative 4 plus 15 is 11 plus 4, getting back to the 15. 6a take away 5a is positive 1a, which you can just write as plus a, and then the minus 2. There's the answer. When you multiply those two trinomials together. Remember, 3 terms are trinomials. Terms are separated by a plus or a minus sign. Okay? So for these ones, we're going to take it one step further. We're going to multiply, but then also simplify after. We're going to multiply the x plus 1 by the 5x plus 3. Then we're going to multiply these 3 things together. and then we'll add the two answers together by collecting our like terms. I'll take it here. Remember, order of operations, say we do, remember BEDMAS, brackets, then exponents. There's none of those here. Yes, there are brackets, but there's nothing inside the bracket that we can do because they are not like terms. And then you divide, multiply, left to right, then you add, subtract, left to right. So again, we'll start by doing the multiplication. So for question A, using distributive property, I'm going to multiply the binomials together. So that's what that shows. That shows me multiplying EX plus 1 by the 5X plus 3. Now for the second part of this, you have three things that are being multiplied together. And when you multiply, you just go left to right. So what that means is I would multiply the 2x plus 4 by the 3. So that would give us 6x plus 12, which is then going to be multiplied by the 6x minus 2. So you're not going to multiply both of those binomials by the 3 and then multiply those binomials together. That would give you the wrong answer. When you multiply things together, you normally just go left to right. So first I multiplied the 3 into the 2x and the 3 times the 4. That's where the 6x plus 12 came from, which then I have to multiply by that second binomial, the 6x minus 2. And so this is a common mistake that some students will do. They will multiply both of them by the 3 and then multiply those two binomials together, and it will give you the wrong answer because you don't multiply them both by 3, just the first one. Okay, so I multiply out these first sets. It's going to look like that. Plus, and now I have to use distributive property to multiply out those last two binomials. So while I'm doing this, I can collect my like terms together for this first part. 3x and 5x add together to give us 8x. 6x times 6x is 36x squared minus 12x plus 12 times 6 is 72x minus 24. And now I can put my like terms together. I've got a 5x squared plus a 36x squared. I've got an 8x, a minus 12x, a plus 72x, and then I have two constant terms, a positive 3 and a minus 24. So that'll give us 41x squared. 8x's take away 12x's is negative 4x's, but then we're going to add 72. That'll give us positive 68x's minus 21. And so there's the final simplified answer. Follow the order of operations. You do your multiplying first, then you do your addition. So let me copy B to a new page here. Now what's different about this one is you've got this minus sign, you're subtracting. But we have to start by doing the multiplying first. So So using distributive property, it would be 3w times the 4w plus 5, and then the negative 2 times the 4w plus 5, minus. Now I'm going to open up another set of brackets here because we are going to have to subtract the whole second part from the first part. So using distributive property for that second piece, it's going to look like this. So next I'll multiply everything out. So I'm keeping those big square brackets in place for now. Multiply out the next parts. My next step, I'll combine my like terms. 15w take away 8w is positive 7w. Three w take away 14w will be minus 11w. So notice I've kept those square brackets there all the way through. And now I'm going to remove them. Remember we saw before, we talked about this when we did our review of polynomials at the start of the semester. A minus sign in front of the bracket does what, Emery? You're not on your phone, are you? Oh, you're just looking at your pencil, playing with it. What does a minus sign in front of a bracket do? Anyone remember? Sorry? That's right, it switches everything inside that bracket. And this goes back to what we learned about subtracting integers. It's the same as adding the opposite. A minus sign in front of a bracket means you're going to take the negative of everything inside that bracket. And so if there was a positive, like the 2w squared, it's going to become a negative. But the negative 11w, you take the negative of that, it's going to be negative 11w, and a minus minus becomes a plus positive. So we've always said a minus sign in front of the bracket will change all the signs inside the bracket. It's the same as taking the negative of everything inside that bracket. So the negatives become positive, the positives become negative. Right, and so what I've usually done next is I've usually collected my like terms. I said you don't have to do that. Right? As long as you're careful, you can just go straight to the simplified answer. 12w squared take away 2w squared is 10w squared. 7w plus 11w is positive 18w. And negative 10 plus 21 is positive 11. So there's the final simplified answer. Okay? So let's skip A and let's do question B. Again, we've got that minus sign in between the two products, so we'll introduce a second set of brackets so that we make sure that we deal with that minus sign in front properly. But the nice thing about this one is the first multiplication is going to be quite simple because it's just 2 times 3x minus 2. That'll give us 6x minus 4. And then we're going to have to subtract the product of those next two binomials. So because I have to subtract all of it from 6x minus 4, that's what the big square brackets are going to tell us, that they're going to subtract all of it. So using distributive property, Multiplying out. And before I remove the brackets in front, I'm going to simplify what's inside those brackets. Negative 20x plus 14x is minus 6x. And now, when you remove the bracket, the minus sign in front changes all those signs. And so we have negative 8x squared, 6x plus another 6x is positive 12x's. Negative 4 plus 35 is positive 31. So there's the final simplified answer. Okay? So on this next page, when you square something, what does it mean? Times it by itself, that's right. Perfect. So what do you think the answer to x plus 5 all squared would be then? Hands up if you say the answer is x squared plus 25. It's not. Those are two terms in the answer, but there's going to be a third term. Because like you said, squaring means multiplying by itself. So you have to go x plus 5 times x plus 5. So there will be an x squared in there. There will be a plus 25 in there. But there's going to be one more term. And so we'll get that again by using distributive property. Same thing that we've been doing. Which gives us x squared plus 5x plus another 5x plus 25 when you multiply out those brackets. And the 5x and the 5x will give you 10x altogether. So yes, there was an x squared and there was a 25, but there's one more term. Positive 10x in the middle. That's what you get. So same thing with question B. When you square something, you multiply it by itself. So it's 2a take away 3 times 2a take away 3. And then we have to again use the distributive property. So multiplying out, we get 4a squared minus 6a minus another 6a. And negative 3 times negative 3 is positive 9. Or 4a squared minus 12a plus 9. So again, there is a 4a squared in it, which is the square of 2a. There is a 9 in it, which is the square of negative 3. But there's one other term in there. Now, here's a shortcut you can use to square any binomial. Okay, you know where the x squared and the 25 come from in that first one, right? Square the first term, gives you x squared. Square the 5, gives you your plus 25. So where do you think that positive 10x comes from, or how could we get it? Here's where it comes from. Multiply the x and the 5 together and double. That's where the 10x comes from. Take the x and the 5, multiply them together, and then double. 5 times x is 5x, doubled is 10x. That's where the 10x comes from. So for question B, square the 2a gives you 4a squared. You got to square both the 2 and the a. Square the negative 3, that's where the positive 9 comes from. To get the negative 12a, multiply these two terms together and then double. 2a times negative 3 is negative 6a, doubled is negative 12a. That's where the negative 12a comes from. You can, if you want, show that you're multiplying the two binomials together like we've been doing here, and then use the distributive property. That works. That's what we did for those first two. But now I've shown you that shortcut, so you are free to use it if you want. To square 3n minus 2m, square the 3n. Remember, you got to square both the 3 and the n. Gives you 9n squared. The last term will be the square of negative 2m, which will be positive 4m squared. To get the middle term, multiply these two together and double. 3 times negative 2 is negative 6, but you're also multiplying the n and the m together. So it'll be negative 6nm, which then needs to be doubled, negative 12nm. That's what you would get if you went 2n, take away 3m, and then multiply that by itself. 3n, take away 2m, and use the distributive property. Okay, so you can do it either way. But you have to remember, when you square a binomial, you just don't square both terms. That'll only give you two of the three terms. To get the third one, multiply the two terms together and double. Or you can use the distributive property like we did for the first two. So let's go down to the bottom one. 3a minus 1 all squared. You can definitely do it using distributive property. When you multiply this out, I'm sorry, this should have been 3a, not just 3. So 3a times 3a is your 9a squared. 3a times negative 1 is negative 3a. And then negative 1 times 3a is your other negative 3a. Negative 1 times negative 1 is positive 1. When you combine those 3a's together, you're going to get minus 6a. Which, if you look at the original binomial, if you square the first term, squaring the 3 and the a, that gives you your 9a squared. When you square negative 1, it becomes positive 1. Multiplying these two together, negative 1 times 3a is negative 3a doubled, will give you negative 6a, that middle term. So you can use that method if you want. Do that next one on your own. Either way, whatever way you feel comfortable with, do that next one, then we'll check it. Good, because I'm going to ask you what the answer is. What'd you get, Sophia? You agree with her, Keen? You agree with her? Yeah? You want to bet a pop on that, Keen? Why not? When you did it, what did you get? I don't know, I'll play your silly game. Should some of them be positive? This is your game. You tell me. Come on, bet, 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 bet. I don't bet with suckers that buy them at the store. Is it right, Princess? Why not?
See, I told you. My God.
Well, you wanted to change them both to positive, Keen.
No, they don't.
Okay, good. Good, good, good.
You're wrong.
Either way, right? You can square it by writing times by itself, or you can use a shortcut, whatever way works for you. All right, let's look at example 4. This painting is called Deep Magenta Square. It can be used to represent binomial multiplication. The length of the red square in the painting is unknown. So let's let the dimensions of that square be x. If it's a square, the length and width, the base and the height are the same. Right? That's what a square is. But the width of the border around the square is 30 centimeters. So that's the border around the square is 30. So maybe I want to move this up inside the square because the width of the border around the square is 30.
Oh my God.
And that was in centimeters. So that's what this is telling us. Just the border, which is the distance from the outside of the red square to the outside of the painting. We want to write a polynomial expression to represent the total area of the painting. So here's how we would do this, right? If we look at the entire width of this painting along the bottom, you've got 30 centimeters on the left side. You've got another 30 centimeters on the right side, which means those two pieces together are 60 centimeters, plus you have the x, which is a dimension along the bottom of the red piece. So that total width would be x plus 60. 30 centimeters on the left plus 30 centimeters on the right gives us our 60 plus x, which is the base of the red square. And the same thing with the height. It'll be 30 centimeters on the bottom plus 30 centimeters on the top plus x, which is the height of the red square. So the height of the entire painting is also x plus 60. So those just give us the dimensions of the entire painting. X plus 60 times x plus 60. So the area A would be base times width or length times height. It's x plus 60 times x plus 60 or x plus 60 squared. So you can use our shortcut to square that binomial. Square the x. Multiply the two terms together gives you 60x. Doubled is 120x. And when you square 60, you're going to get positive 3,600. 60 times 60. 6 times 6 is 36, and then there's 2 zeros because there's 1 0 in each 60. So there's an expression for the area of the painting. Then it says, what is the total area of the painting if the red square has an area of 3,600? 3,600 square centimeters. So the red square measures x by x, or x squared, and that must equal 3,600 centimeters squared. So this is what we're going to do to figure out what x is, and then we'll answer the question, which is what is the total area of the painting? So I've got this equation again. It comes from the area of the red square is base times height, x times x is x squared, and we're told that that area is 3,600. right? So Peyton, what do we do next? After you put your damn phone away. What do we do? Can't yet. We have to figure out what x is first. How do we figure out what x is? X squared is 3,600. How do you get rid of this squared up there? What's the opposite of squaring? Yes. And whatever you do to one side, you have to do the same thing to the other. So the square root of x squared is x. On the right side, the square root of 3,600 is 60 centimeters. So that is what x is. We want to know what the entire area of the painting is. So that painting is a base of x plus 60 and a height of x plus 60. But now we found that x is also 60. So the area of the entire painting, which again is x plus 60 times x plus 60, except now I found what x is. We just calculated that x itself is also 60. Which means you're going to have 120 times 120, which is 14,400 centimeters squared. There's the area of the entire painting. $120 times 120 is 14,400. So what I did is I went 12 times 12, which is 144, and then you have to add 2 zeros on. So this next one, you're building a skateboard ramp. You have a piece of plywood with dimensions 4 feet by 8 feet. And you cut x feet from the length and the width. Sketch a diagram showing the cuts made to the piece of plywood. What is the area of the remaining piece of plywood that would be used for the ramp? So here's what this looks like. So we have a 4 by 8 sheet of plywood. And x feet is being cut from the length and the width. So that's what this is showing. Originally, the plywood was 8 feet by 4 feet, but x is cut from the width and x is also cut from the length. So there's a diagram that shows the cuts made to the plywood, and we've labeled the dimensions. So we want to find the area of the remaining piece of plywood. That's what part B is asking us to do. So to do that, we need to come up with an expression for the length and the width of the piece that's left, which is the piece in the upper right-hand corner. The original length was 8, but then you took x away from it. You cut x off, which means the new length would be 8 minus x. And the height was 4, but again, we cut x off of that, so the new height would be 4 minus x. That's the dimensions of the piece that's left. So for part B, to find an expression for the area, which is all we're going to have here, there's no way we can figure out what x actually is. So we're just going to write our answer as an expression. By using the distributive property, we'll multiply these out. So that'll give us 32 minus 8x minus 4x. Negative x times negative x is positive x squared. And normally when we write polynomials, we write them in order of descending power, highest power to lowest power. So there's an expression for the area of the piece that's left. So, I mean, sometimes you're going to be asked to do things with polynomials where it actually gives you an expression that can be tied to a practical example, like these last two. And in the case of the first one, at the top of the page, we're actually able to get a numerical answer based on the information we're given. Question B, we didn't have that information to figure out what x is, so our answer is just an expression. Okay. So you can work on page 210, 211, number 6, and 7. I will post these, and actually 10 as well. There's just one part for number 7, one part for number 10. So I will post these solutions to Google Classroom so you can check your work. Okay? Not this one. But I think the next one will be